Our focus for this class is the joint variation, as you can see on the screen. What then is joint variation? Let me give an illustration so that you will understand what joint variation is all about. Okay, so when the value of a quantity is proportional to two or more quantities, okay, we say that a joint variation has occurred. All right, for instance, if the volume of a cylinder, let the volume of a cylinder be equal to V. So let V equals the volume of a cylinder. So the volume of a cylinder V varies jointly as the height. So H is equal to the height of the cylinder. Okay, and also directly as the square of the radius. So R is the radius of the base of the cylinder. Okay, now how do we relate these three parameters together? Okay, remember I said that joint variation occurs when a quantity is proportional to two or more quantities, and in this case the volume is proportional to the height and the radius of the base of the cylinder. Okay, so how do we relate this? We can have V to vary as the square of the radius. We said it varies as the square of the radius and the height. Okay, introducing the proportionality constant and then removing the variation sign, we have that V is now equal to KR square H. But mind you, in this case, the proportionality constant will be equal to pi. Okay, so where K is equivalent to pi. Okay, so this equation now becomes V equals pi R square H. And that is why we have the volume of the formula for the volume of the cylinder to be equal to pi R squared H. And why are we using pi? Because pi is the property of the substance we are talking about, okay, which is the circular base. All right, so this is just the introduction to what joint variation is. In the next slide, we are going to study some examples and then see how we can apply our knowledge of the joint variation. So let's go to the problem solving approach. Here is the problem. We're asked to find these values. Okay, we're told that if A varies directly as B and this same A varies inversely as the square of C, if B equals 30 and C equals 24 and A equals 1 over 8, find the law connecting the variables. Why do we have to find the law connecting the variables first? Of course, without finding the law connecting the variables, you cannot solve anything further. Okay, so that is the first thing, to find the law connecting the variables. Even though you're not required to find it, you have to find it first before you can solve further. So after getting the laws connecting the variables, the next thing is to find the value of A when B equals 5 and C equals 2. We can just spare ourselves this bogus question by solving or bringing out the mathematical expression for this particular problem. And to do that, let us go over to the problem solving approach. We were told that A varies directly as B. Okay, that is the first statement. And we said A also varies inversely as the square of C. Varies inversely as the square of C. From transitive property, if A varies directly as B and A varies inversely as the square of C, you will agree with me that A, this could be simplified to be A varies as B and varies as 1 over C squared. Of course, this can be approximated to A varies as B all over C squared. Okay, so this is the simplified version of the problem that we've analyzed. All right, so let us now introduce the proportionality constant. If we do that, A will be equal to KB over C squared after introducing the proportionality constant. Of course, we'd have to find the value of K first before we can now solve further. Like I said, the equation connecting the variables would be deduced after obtaining the value of K. So from here, we can say that K is equal to AC squared all over B. We just made K the subject of the formula. All right. Now, after doing this, we're told from the question that if B equals 30 and C equals 24, then A is equal to 1 over 8. Okay, if we substitute the values inside this equation, we have K to be equal to A is 1 over 8 times C is 24, but we have C squared times 24 squared all over B, which is 30. Okay, so this is the same thing as saying 24 times 24 over 8 all over 30. Okay, and this is here 1, here 3. So we have 3 times 24 over 30. So K is equal to 3 times 24 all over 30. So 3 cancels, 3 goes here 1, 3 goes here 10. So we have this to be equal to 24 over 10. And dividing through by 2, you would have this is 12 and this is equal to 5. Therefore, K is equal to 12 over 5. That is the value of K. If we now decide to put this value of K inside, which equation are we going to put it now? Your guess is as good as mine. You have to put it inside this so that we can obtain the subsequent values. Okay, so when we do that, we have A is equal to A is equal to KB over C squared. Is that correct? Yes. But we are told that K is equal to 12 over 5. So we have this to be equal to 12 over 5B all over C squared. You can simplify this further to be equal to 12B over 5C squared. Right? That is the relationship between A, B, and C. The next question is to find the value of A when B is equal to 5 and when C is equal to 2. So when B equals 5 and C equals 2. I think that is it. Yeah, when B equals 5 and C is equal to 2. So we have to substitute the values of B and C into this particular expression so as to get the value of A. So if we do that, we have A would be equal to 12 times 5 all over 5 times C squared, which is 4. Okay, 2 times 2 is 4. This will cancel out, and this goes here 1, this goes here 3. Therefore, A is equal to 3. So when B equals 5, C equals 2, therefore A is equal to 3. And this is our final answer. This is where we draw the curtain for this class on the joint variation. If you have questions, please kindly drop them in the comment section or in the chat section on the platform, as our lead instructors will be available to attend to them. So see you in our next class, where we'll wrap it up on the concept of variation with the topic partial variation. And I'm sure you don't want to miss it. Bye.